Great. Thank you for coming back. The second session this afternoon, we give thanks to Phil Crump for actually coming along to talk to us about HamTV, the link from the ISS to the ground on many of the school's contacts. Over to you, Phil, for something very interesting.
Thank you. Good afternoon, everyone. So I'm Phil Crump M0DNY, and I'm going to talk a bit about HamTV, particularly about the ground stations, and also about what we're doing with the ground stations to support the operational contacts. So a bit of background on me to start with, relevant to this. So I actually got first involved with this where we were doing the AMSAT-UK streaming as part of BATC, and Kieran asked us in 2016, can we support the streaming of the Principia contacts that Tim Peake was doing. While doing that, then we had HamTV come online, thanks to Tim on the space station, tracking down a vital cable up there. And so helped Noel, who was primarily running that at the time, particularly with use of the Goonhilly 99 ground station at Goonhilly. While we were working with that, I'll talk about some of the challenges involved in that, and we ended up coming up with this transport stream merger. Phil Heron, MI0VIM, came up with a concept of how we could merge multiple ground stations to produce one feed with less errors. We deployed that as part of helping some of the European contacts, as well as for the latter Tim Peake contacts. We're just starting to get into the pace of using it in 2017, and then HamTV had the failure of the transmitter, and since then I've been waiting for it to come back so that we can get all this stuff up and running again. So first of all, a little bit about the HamTV transmitter itself. So you can see the transmitter here in this photo, the blue box. So it's 2395 megahertz out with about 2 watts, we reckon, into the feed. So the actual transmitter in there has about 5 watts out, but then there's quite a bit of coax and a filter in line that probably mean there's 2 watts, maybe even a little less. Actually reaches the antenna on the outside of the space station. The transmission is DVB-S, so that's DVB-S1, not S2. 2 megasymbols, so 2 megahertz wide with a bit of roll-off. FEC a half, so the combination of the QPSK gives us 2 bits per symbol, and then the FEC a half means we get about 2 megabit data throughput from it. The transmitter has analog video and audio inputs. It's designed to work with the older cameras that were on the station that had these outputs. And it encodes it into MPEG-2 video and MP2 audio, which are quite old video codecs by nowadays standards. But it does use quite a bit of bit rate. So we've got 50. These rates have actually changed slightly. They were reprogrammed when the unit was repaired. So they've upped the video bit rate and lowered the audio bit rate. We don't tend to use the audio from this, so we're quite keen to get a bit more quality out the video. The video quality is not great from what we're used to nowadays with HD YouTube streaming and such. So it'll be interesting to see this time how much more quality we get out the video with that little bit of extra bandwidth there. So the intention of use for this, the HamTV transmitter up there, we have the ARIS contacts, which Kieran is going to talk quite a bit about later. We use VHF, UHF voice, FM voice for asking the questions and the astronaut responding. The HamTV is then an add-on to that. So although we have audio on the HamTV, we don't use it in the contact. The VHF, UHF voice is for that because that's always going to be the more reliable. But the HamTV does provide an extra facet to it. It gives a way that the astronaut can do something visual while they're talking to the students. It'll often start with them just waving at the camera, but we've also had ones where, as Tim is answering the questions, he slowly floated upside down and then appeared to realize he was upside down and then correct himself, which caused a laugh from the kids. The other side to that is, so as part of ARIS UK, we often go and take the large ground stations there with the large trailer mast and VHF, UHF Yagis, And this gives us another aspect to talk about. So we've got some microwave alongside the VHF UHF, some dishes alongside the Yagis. It gives another thing that we can talk to the students or whatever the current audience is about how the antennas are working and how they're enabling what they're seeing in front of them at the time. Just to quickly run through the recent history. So I mentioned that we had the failure of HamTV in 2017. That blue box transmitter was then brought down from the space station. There was only one unit made. There was no spare. That was brought down. It was taken back to Kaiser Italia in Italy, and they then repaired it. It then went through a bunch of recertification to go back up. Finally got upmasked to the station earlier this year. And then finally commissioned and activated on 29th of July this year. So it's just been on for a couple of months. So as of right now, the transmitter is on. We've had a bunch of people receiving it this morning. Not here, but on other ground stations. We have noticed a few differences with the HamTV downlink. So video sync detection feature has been added. So previously, when there was no camera plugged in, which was 95% of the time outside of the school or educational contacts. We had a blue line down the left, which was the NTSC video input not detecting a sync. And we had an audio hiss. You could hear the system hiss of the space station and all the electrical noise of the space station on the audio channel, which was actually pretty cool. Now they've added sync detection, which mutes all that when there's no camera plugged in, which several of us find quite disappointing. It's a lot neater from a technical point of view, but it's actually a lot less fun to see at least something of what's going on. So currently, this is a screenshot of VLC playing what we currently receive from the space station as no cameras yet been plugged in. So it's just a totally black screen. Nothing to see, nothing to hear at all. The other thing that we see in this is that the resolution, you probably can't quite read it there, but it's reporting 352 by 480, which is a bit of a strange resolution. It's halved the horizontal resolution of the video. We think this is just part of the blanking. It still reports 16 by 9, and we expect it to fully revert as soon as they plug a camera in. This has caused us some issues with preparing for when a camera gets plugged in. But we are still expecting, as soon as that camera gets plugged in, that we'll go back to the video we saw before. One of the other changes that they have made when they repaired it was to adjust it so that it now sends the 16 by 9 aspect ratio. So before we had an issue where it was showing up 4 by 3, and so you got a slightly stretched astronaut. Now you should get a correctly proportioned astronaut from it. A little bit about the antenna that's being used on the space station. This is actually quite relevant to the performance of the ground stations. So these photos are of the space station, but in fact I'm going to point at this one so I don't have to walk around Barry. These photos are upside down, so the Earth is at the top. It was just the way that these photos are taken. The antenna that we're using is actually this one here. The one that's shown by the arrows, but there's one here and there's one here. This one's ARIS 41, which we're using. It's a dual L and S band patch, which we're just using the S band side of at the moment. But one of the things to note here is the nadir of the module is basically nearly along the top here, and this is 15 degrees back. So it's pointed 15 degrees backwards behind the space station. So it's not quite on the bottom of the space station. And that means that as it comes over the horizon from the west, it's actually really hard to see as it comes over the horizon. You have to wait for it to come up to about 10 or 20 degrees before you can see anything of it, even with a big dish. When it's going down on the east, you can see quite a lot of it. You can see it nearly all the way to the horizon if you have a large antenna for that. One of the other things you can, or at least if you're watching this on YouTube or online, you'll be able to see better. But there's virtually nothing here in terms of structure. So we don't get very much blockage, except we have these large solar panels. So there's a large solar panel here for those in the room. We do see unexplained blockages or LOS on some ground stations that's not on others. And we reckon some of that is due to when the geometry just puts the ground station behind where the solar panel is. It then blocks it for one particular ground station, which again causes a problem if we're trying to provide a constant video feed to the schools. So a quick overview of the ground station. Basically, I'm going to run through a quick overview of the ground station, some gotchas with the ground station, and challenges that we've had in setting up the ground stations. And then I'm going to talk a bit about the merger side and what we actually do for the operational contacts. So this is an overview of a typical ground station setup. So you've got your dish or antenna. You can just about get away with a helix antenna or such. But you then need a low noise amplifier for 2.4 gigs. A filter is pretty much a requirement nowadays with 2.4 gig Wi-Fi and with 4G in this country as well. I'll talk a bit about that. A line amplifier, because your LNA probably doesn't have enough gain. And actually, if you put a really high gain LNA here before your filter, you can end up overloading that. So the best way to do it tends to be low noise amplifier, filter, and then more gain. You then might want to put a down converter in. A few of us run this all at 2.4 gigs, but then that does mean that your receiver at the far end needs to be capable of 2.4 gigs. So I'll run through a few of the receivers, but things like, for example, the mini tuner hardware receiver, of which you'll see a few on the BOTC table downstairs, that is capable of 2.4 gigs out of the box. The disadvantage, of course, is that your coax that is running from the masthead to the shack then needs to be able to carry that 2.4 gigs without too much loss. So if you try and do it over RG58, your receiver's not going to see anything, however, without a lot of gain up here, basically. The other side to this is you need a way to point the antenna. I'll talk a bit about dish size and pointing in a second, but generally a computer-controlled way of doing that makes it a lot easier to run the passes. So starting on the left on that one, the first thing is the dish size. So there's often been a lot of people wanting to go for large dishes on this. And certainly we see people putting up 1.8 meter, 2 meter dishes. You don't need something that big at all, really. If we run through from here, so for example, I've been working with a 0.9 meter offset antenna that I got off eBay. It's a satellite offset antenna. Your typical satellite dish, basically, 0.9 meter diameter. And on an overhead pass, I will see an MER of over 12 dB, often quite a bit more than that. With the half FEC on DVB-S, the particular mode we're using, we need plus 1.7. So there's about 10 dB of margin in that. As we go down in elevation, of course, as the satellite's going through the pass, when it's overhead, it's about 400 kilometers. And then as the elevation goes down, that distance dramatically increases. So this is where you start to need the extra gain. But if we go down in elevation, we can still see, at 20 degrees elevation, we've still technically got about 2 dB margin. So we're probably looking at an MER of about 4 here. Now that is very borderline. Any sort of weather or such is probably going to push you below that. But one thing to note here is, can you actually see down to 20 degrees elevation from your QTH? And remember, of course, this is S-band that doesn't go through trees nearly as well. It doesn't go through buildings. And actually, if you can only see reliably down to about 30 degrees, then you've still got 5 dB of margin at the point that you lose it due to the obstruction. And so at that point, 0.9 meter is perfectly adequate. The other thing to look at from here is if you're just after getting started on this and trying it out, actually going down to a 0.6 meter or something like that, yes, okay, you'll probably only be able to see it down to about 30 degrees at the lowest and probably reliably only above 45, But that's going to get you a couple of minutes that you can see, and it's also a lot easier on the pointing side of things. So on the pointing, looking at the 3 dB beam widths of various sizes of antennas, a 0.6 meter, you can do plus or minus 7 degrees on getting the pointing right. And of course, this pointing error has to include how well you're calibrated, how well your antenna is calibrated, how well your rotator is calibrated, how much your mast flexes or such in the wind. So actually having it on top of a tall mast is not so great. And any other errors in that, like a joint slipping over time or something like that. So as you go up in size, that really starts to tighten down. And then if you're looking at something like a G5500, so the Yaesu G5500, very common thing that a lot of us use, the actual specification for that in the data sheet is plus or minus 4%, which is plus or minus 14 degrees, which doesn't line up to this at all. But if you calibrate it carefully and also check that it's still calibrated, sometimes the pots can wander a bit, then it is possible to use, but I would still say even then 1.2 meter is probably the maximum size of antenna you want to put on that. So this really becomes a lot easier with the 0.6. With a 0.6, you can easily hand steer the thing. And actually, I'll show you a photo later in the examples of a hand-steered antenna mounted on a tripod with a basic theodolite arrangement for working out the current elevation angle. And that works perfectly fine for getting a signal for a few minutes. The other thing to mention with the hand pointing, though, is, of course, that does mean you have to be standing behind the dish, constantly pointing it during the pass. And if you want to be tweaking anything else in the system or trying something out, then you can't do that at the same time as pointing it. So it is quite useful to have some motorized solution. There are better rotators available than the G5500. There's, of course, the SPID systems and such, but they really do get quite expensive at that point. One of the other pitfalls is system noise figure. So one of the suggested setups that we've seen that people have been looking at is this chain on the top, which is pretty much the Noelec special. So that's what's here. So Noelec sell a wideband LNA, which works up to 2.4, a HamTV, which has a 1.5 gig LO in it. So that'll take 2.3 gigs or 2395 down to 895, which is in the frequency range of an RTL SDR. So suddenly you can receive it all on that. However, this wideband LNA only has a gain of 12 dB. Yeah. The HamTV then is totally passive and has a loss of 10 dB. And then because that's totally passive, you've also got to add in the noise figure of the RTL SDR behind it. And you end up with a system noise figure of about 5 dB from that, which is more than the difference. I think I worked it out here. That is more than the difference between a 0.9 meter and a 1.2 meter dish, where a 0.9 meter is a lot more manageable. So the answer here is that you would need a bit of extra amplification, so the line amplifier that I was talking about, to go behind the LNA. But here this brings us into the next point, which is that you want enough gain to get over the noise figure of the components and also cabling loss as well. You want enough gain to get over that such that your system noise figure is good. But if you have too much gain, you can end up overloading your amplifiers, particularly with RFI, which I'll talk about on the next slide. In terms of cabling, just because I've got a couple of examples here, at 2.4 gigs, this kind of semi-rigid stuff is quite good. These flexible cables, I've had mixed results with. I've had some that ended up having about 6 dB loss for that length of cable. I think due to too much bending, but I think I've also had a couple out of the packet that have not been great. RFI, this is one of the most this ties in with everything else to be one of the most difficult to deal with. So this is a spectrum from G8FXB in Essex. This is the HamTV signal. So he's got about 8 dB signal to noise here. So it's not great, but it's perfectly decodable. This is the 2.4 gig Wi-Fi. And then this is his local 4G. Now, the 2.4 gig Wi-Fi, you can see here the purple is the max hold and the blue is the current. The Wi-Fi is very peaky. It depends on how much people are watching iPlayer or YouTube on the Wi-Fi. But it is quite high power on those peaks. And if your system is being overloaded on those peaks, it can mean it breaks the lock on the receiver every time the peak happens. And that can easily happen 5 times a second. And so you never see any video, despite the fact that when you actually look at this on a spectrum analyzer, you won't see very much there at any particular point. The other one that's come in is this new 4G band. This appears, as far as we can tell, to be a UK-only problem at this point. This bit of spectrum, 2350 to 2390 megahertz, was sold to Telefonica in 2018. So just while HamTV was being repaired, Telefonica were deploying these masts all over the country. And the main problem there is the sheer amount of composite power in it. So it's actually quite constant power, but the power density in there means that if you don't have a filter on this, you end up running a very high power through your system just to be able to pull HamTV off the noise floor, but you still have to deal with this. And yes, that can cause an issue, particularly at low elevation if you happen to be pointing at the 4G tower, as you're doing it. So the answer to that is filters. So this is a couple of filters that I have. There is not currently an off-the-shelf solution for this. These two are both from Aerial Parts. And we've actually been talking to them about creating one that's specifically for 2395. This one is actually an early prototype model of that. The first one is a standard 2320, so 13 SEMS filter that I retuned. You probably can't see this too well, but this is on the same 100 meg span as the previous slide. 5 dB per division, so 50 dB top to bottom. And the 100 meg filter only slightly, the 3-pole filter here only slightly cuts down. The 5-pole filter is a lot sharper, like that. And so really you end up needing something of the order of this to get a significant power reduction. So as an illustration of that, the top here is the spectrum I see on my home station with no filter. Bear in mind, I have no 4G band where I am, which seems to be very lucky because everywhere else I've set up a station, it's been there. But you can. This is Wi-Fi channel 1 over here. And this is with the 5-pole filter installed. So you can just see a bit of the Wi-Fi here. You can see the noise floor where I want HamTV, which is what I want. I don't want to suppress that, but everything else is suppressed off. And looking at the power, the RF power reading that came through this, no filter minus 30 dBm, with filter minus 48. So I have 18 dB that I don't need to scale the amplifiers for. So that's 18 dB of dynamic range margin. I believe if the 4G was present, we'd have about, it'd probably be up to around 22, 23 dB of margin there, or of extra margin. Moving on in the overview to look at the receivers. How am I doing on time? Okay. These are two examples of receivers. So we've got the hardware mini tuner that's based around a satellite TV set-top box NIM. This is a BATC project that's been really the cornerstone of a lot of our DATV receivers. This works great for it. There are software-defined solutions like SatDump on the right. So this is a pass that I was receiving. We've actually got a ham-it down, one of those ham-it downs just in the corner there, plugged into an AirSpy, and then running SatDump, and that was decoding quite nicely as well. Some examples of the ground station. I find it's always useful to just have some photos of what other people have set up. So this is a wider photo of the sat dump setup that I had with the 0.9 meter satellite dish that I talked about that I've been using on a G5500. This is 1.2 meter on a rotator that's used by an Italian ARIS station. They're a proper telebridge station. This is a 60 centimeter on a camera tripod. There's a spanner hanging down here, which was used to check the elevation angle against a piece of cardboard that we'd marked angles on. But with a 60 centimeter, that worked totally fine. And the elevation of the other buildings around was quite high. So any time that the ISS was not behind a building, we could see it. On the right, we've got one of the antennas, which we luckily have partial use of at Goonhilly, which is a 5 meter S and X band. It's very nice. Totally overkill for this. But it also struggles because it can't see it in that first 5 to 10 degrees because the antenna is obstructed by the station. We also do see outages from that, we think, when the solar panel gets in the way. So that can't see anything, even with all that gain. And at that point, someone with a 60 centimeter who's at the other end of the country can see it fine. So this brings in wanting multiple ground stations. So other challenges of when we use this to support the actual educational contacts. So on the left here is Noel's old Land Rover, which Mike now owns. With the mast, we had HamTV dish at the top, Wi-Fi link back into the venue. Noel did a presentation a while back, which I believe is available online, on how he would calibrate this, and he ended up with a full procedure of how he calibrated the pointing of the Land Rover every time he parked it at the venue, because, of course, once it's all the way up there, you can't easily check what direction it's pointing in. This had to be done at every contact. We normally set up in about 24 hours in advance. So we've got that to do the pointing calibration. We've got to deal with the RFI, any RFI from Wi-Fi or such. And we have had Wi-Fi systems that have not been behaving and have actually been transmitting over 2395. And those had to be tracked down on site and unplugged to allow us to receive anything. And then all the standard portable station challenges of you get there and one of your connectors is loose or such and needs to be fixed, or one of your cables is dodgy, or you're trying to do it in the rain, set it all up in the rain without getting water in the feed and that kind of thing. The main thing here, though, of course, is we enjoy the technical side of this, but at the end of the day, we want to give the experience to the audience. And if we can have a great day troubleshooting and fault finding, and if we can't fix it at the end of the day, the audience doesn't get anything. So we do need a bit of that reliability to support the context. So the first solution we had for this, Noel put together a web page here with a bunch of the old streamer players from the old BATC streaming system using RTMP flash streaming, which is very nicely low latency for this. And we got each of the ground stations to stream in their video into this, and then we would open one of them up, and then when they seemed to be losing it, we'd take a look at another one and maybe full screen that one over the top if that one was better, and switch between them. And it worked. It looked very clunky from the audience point of view. Sometimes the delays were a bit different, so they sort of saw a bit of a rewind or a bit of a fast forward. So we were thinking, how can we do better than this? And so DVB-S uses an MPEG transport stream where everything is packetized. And is there any way from a set of incomplete streams that we could reassemble a full stream? And this is where Phil Heron came in. He had a look at the transport stream, and some packets have a PCR timestamp that is steadily increasing on a 27 megahertz clock, I believe. And we can use this to synchronize the ground station feeds. There is a continuity counter that runs between this, but the continuity counter goes up to 16, and with only every 1 in 50 packets having a PCR, you can't quite fully reassemble between these. So we actually use PCR segments to switch. So the way we've implemented this is we have a 100 millisecond delay on a central server. Everybody streams their transport stream up, and then we switch between the stations depending on whether they're reporting a full PCR segment. Basically, the earliest one that exists currently gets copied to the output, and then that's pushed out. And the output then looks like a standard transport stream, but it contains only the bits from the stations that have reported complete PCR segments. And so this contains vastly less errors than one lossy station. But if you've got two stations that are both losing alternate bits of it, you can reassemble a full feed. And it also means that when you even if there's a clean handover to another station, it happens automatically without needing any manual input. So in 2017, we ended up using this quite a bit. This is a particularly high-profile contact with Jack Fisher, which was a contact done in Texas, I believe, but it happened to be, because the ISS wasn't on waking hours over the US, we ended up doing a telebridge to Europe for that one. And so we had several European stations. We've got Goonhilly, we've got my home station, we've got a French Jean-Pierre's station, Router, PA3WG's station in Netherlands, and IK1SLD in Italy as well, all feeding the merger for this, provided one video stream that was then streamed into the venue and displayed for the kids to watch while they were talking to the astronaut. This system was then also used for contacts with Paolo Nespoli and Thomas Pesquet as well. So now we're looking at setting now HamTV is coming back again. I think Kieran's probably going to talk about it later, but we have the contact. We have an educational contact with some scouts in Warwick next weekend, and this will be the first time that HamTV is going to be used again since it's been repaired. And we're looking for ground stations to join us in helping to fulfill the network for that. So we've started to get a few online, but more is always better. So in terms of technical requirements for this, there is a full list on the wiki, which I'll link to at the end. There's a lot more documentation on the wiki. I appreciate I've been skimming over a lot of this. But basically, we're looking for anyone with mini-tune receivers, ports down receivers, now have a receiver built in, or sat dump using an SDR. For mini-tune and sat dump, you need an extra little application, which we've called DVB push, which is this little app that takes the UDP in there, and then it batches the UDP and sends it up to the server. For the ports down solution, that's actually now built into ports down. You need a reliable internet connection to upload it, just so that we're not losing half the packets that you send up. And then we have an onboarding process where we basically do some tests with you and just check that your internet is working as expected, check that you're happy with how the software is functioning, and help you with any issues you might have. And then we add you to the public merger system ready to support the contacts. So there's a few links up here. The live.aris.org website is the key link there. There's the main page, which runs the streams, but there's also the HamTV/HamTV also linked on there, which is where we have the current merger webpage that you've seen a couple of times with the contributing stations. In terms of technically diving into this a lot more and how to do it and where to find the parts, the BATC wiki is where we've been collecting that information. There's several sub-pages here on ground station construction, how the merger works, and a bit more on the technical details of HamTV transmitter itself. And then ARIS International have also recently set up a Discord server on which we have a dedicated HamTV channel that you can talk to us more about. We're also posting what we're doing on there and encouraging a bit of collaboration on there. That's it. Thank you.
Thank you very much. I think that's a massive demonstration of how much goes in to make sure how the HamTV works. I found it amazing to see the background, and thank you for all the dedication the team have been doing on that side. I'm pretty sure there's going to be some questions. Questions? No?
Hi, Jen, G4HOZ. Thanks, Phil. That's really interesting and encouraging. Now, I know from reception over the last few months, there have been the odd time when it's been switched off. And I've looked at the ARIS site and it said, switched on, switched off, switched on. It doesn't really give you information. Have we got any hooks into NASA to get some real up-to-date information about when it's actually on or off?
So the best place to look on that is the social media accounts of ARIS International. There was a time recently where we were expecting just a few days outage because currently the HamTV transmitter shares a power supply with another experiment. They were scheduled to have the power supply for a few days, and then their experiment overran for 2 or 3 weeks or so. And so during that time, although we were scheduled for it to come back on, we couldn't because they had the power supply, and we were also unsure when they were going to be able to hand it back to us. So normally the ARIS International Twitter account is the best place to have it. At that point, we didn't know, or ARIS internally didn't really know what the timescale was, which is why there wasn't much information on that. But generally, they're quite good at giving you dates. Social media is the one to check, yes. Yeah, there's a definite push to put out as much information as they can on there.
Thank you, Phil. Any other questions?
Phil, great talk. I was thinking laterally a bit here. I was just wondering whether this merger of transport streams also included sound. Maybe it does it? Okay.
It does.
And whether it's potentially compatible with H.264 as well. The reason I'm asking the question is I'm thinking a bit laterally about diversity reception at repeaters. That's the idea there.
Okay, so the merger concept really is just working at the MPEG transport stream level. So it's independent of codec or independent of the PIDs involved or such. So yes, it would be fully compatible with that, I believe.
So potentially diversity reception would be another application for it.
Yes, yeah. I stressed a bit there the internet connection side of things. So one of the things is that all the packets have to arrive at the server at a roughly predictable time, plus or minus 25 milliseconds or so, which has been an issue on some people's internet connections before. So with a bit of attention to that, it should be fine.
Thanks. Any more questions? In that case, could I ask you to show the usual thanks to Phil for such a good talk? Thank you.